Today, we will solve a question on graphical method. The question on the board is solve the following linear programming problem by graphical method. And I've explained the steps to be considered in solving graphical method. By being given the graphical method question, that is, we should solve this LPP in graphical method. These are our objective function. These are what? These are our constraints, and these are what? Negativity, non-negativity constraints. Our solution, our first solution is what? Our first step in solving LPP in graphical method is what? Formulate the linear programming problem. As you can see on the board, the question has been formulated. Our next step is to what? Is to change the inequality sign to equality. So our constraints x1 plus 2x2, x1 plus 2x2 is equal to 40. 3x1 plus x squared is equal to 30. Then 4x1 plus 3x2 is equal to 60. Then our non-negativity x1, x2 is greater than or equal to 0. That is, our x1 here must be greater than or equal to 0, and our x2 here must be greater than or equal to 0. Since we turn our equality to equalities, this has been applied that as we change all the constraints sign to the equality, it means that our x1 will be 0. What is the value of x2 we get? Our x1 here will be 0. What is the value of x2 we are going to get? We are going to do it for x1 and also as x2. So the point that we are going to get here will not be our coordinates. We will now plot it on a graph. So that is what we call graphical method. So the first constraint is x1 plus 2x2 is equal to 40. These are our first constraints. So let's say when s is 1, when x1 is equal to 0. Why are we saying it? Because we have turned the inequality to equality, and by doing this, we have to consider x1 as 0. We have to get the value for x2. So we consider x2 as 0. We're going to get value for x1. So since we have x1, when x1 is 0, what are we going to get? It means whenever you see x1, you're going to put 0. You're going to have 0 plus 2s 40. So from here, 0 plus 2s subscript 2, I'm going to get 2s2. If you take 0 to the constant here, it will be 40 minus 0. So 40 minus 0 will get 40 is equal to 40. Divide both sides by 2. So you are going to get s2 is equal to 20. So this means that when our x1 is 0, what do we get? When our x1 is 0, we get s2 as 20. This is our first point here. So let's consider the second constraint. 3s1 plus s2 is equal to 30. So when x1 is 0, when x1 is equal to 0, it means whenever we see x1, I'm going to put 0. We're going to have 3x1 is 0 plus s subscript 2, then it's equal to what? 2. So from here, 3 times 0 is 0. We have 0 plus s2 is equal to 30. So 0, if you take 0 to the constant, it will be 30 minus 0, which is 30. We are going to have s2 is equal to 30. So it means when our x1 is 0, our s2 is what? 30. You will write the point out. Then we have to consider the last constraint. As it is our third constraint. 4x1 plus 3s2 is equal to 60. When x1 is equal to 0, when x1 is equal to 0, what is our s2? It means we are going to put x1 as 0 plus 3s2 is equal to 60. If you multiply 4 by 0, you are going to get 0. This is 3s2, then it's equal to 60. It means that what? You have to divide 3. You have to divide 3 by 3. You have to divide 3s2 by 2, then 60 by 3. So that we are going to have s2. So if you divide 60 divided by 3, you are going to get 20. So it means when x1 is 0, yeah, our s2 is 20. So it means each value, this is x1, this is s2, this is s1, this is s2, this is x1, this is s2. Then since we have gotten this, we have to go to the constraint, to the first constraint, second constraint, and the third constraint to get the value for s2. That is, if you put s2 as 0, what are we going to get? Let's try it. So our first constraint is x1 plus 2s2 is equal to 40. So when x2 is 0, when s2 is 0, we have considered when s1 is 0, we get this point. So let us consider when s is equal to 0. What are we going to get for x1? We are going to get, whenever you say s2, we are going to put 0. x1 plus 2, 0 is equal to 40. If you multiply 2 by 0, you are going to get 0. If you take 0 to the constant here, to be 40 minus 0. So this equivalent that our x1 is what? It's equal to 40. So it means when our x1 is 40, when our x1 is 40, our s2 is what? 0. So when you have to do it for second constraint, when s2 is equal to 0. Or you can write your second constraint first. Our second constraint is 3x1 plus s squared is equal to 30 when s2 is equal to 0. So it means you have to be putting 0 whenever you see s2. 3x1 plus 0 is equal to 30. If you take this constant to the other constant, it will be 30 minus 0. 30 minus 0 is what? 30. So this equivalent that 3x1 is equal to 30. You want to get a value for x1, you have to divide it by 3, divide it by 3, so that you are going to get x1. Your x1 will be what? 10. So when your x1 is 10, your y2 is what? 0. This is the point for second constraint. So your last constraint is what? 4x1 plus 3s2 is equal to 60. So 4x1 plus 3s2 is equal to 60. So it's equal to 60. So when x1, when s2 is equal to 0, whenever you say s2 put 0, you are going to have 4x1 plus 3, 0 is equal to 60. If you multiply this one by this, you are going to get 0. We now have 4x1 is equal to 60. If you divide both sides by 4, what are you going to get? This will be able to cancel. You are going to get x1 is equal to, how many 4 will you see in 6? 1. 1. You made that 2. We add it to here to be 20. How many 4 will you see in 20? That is 5. So this implies that when our x1 is 15, our y is what? 0. That is, our x1 is 15. Our x1 is 15. Our y is what? 0. So these are the points. So these are the coordinates of the constraint. So we are going to locate it. We are going to plot a graph on it. It means we have to solve when x1 is what? Here, when x1 is 0, y is 20. So we are going to plot the graph here also. When x1 is 0, y is 20. We are going to mark or draw the graph on it. When x1 is 40, y is 0. We are going to draw the graph on it. When x1 is 0, y is 30. And when x1 is 10, y is 30. S2 is 0. When x1 is 0, s2 is 20. When x1 is 15, s2 is 0. So in this case, this can be in form of, because of this is, if you plot this, if you plot when s is 0, y is 20, it will be just in a straight line. So it means that our x1 here will be 40. This is what? 40. This is what? 20. It means we can mark 40 to 20 without, we can remove 0, 20, 40, 20 by saying that 40, when s1 is 40, our s2 is 20. When s1 is 10, our s2 is 30. When s1 is 15, our s2 is 20. It's also the same. So I will show you how to draw the graph on how to plot a graphical graph, how to plot the graph for this linear programming problem. So we have to plot our coordinate of the constraints on the graph, so that when we plot it on the graph, we're able to get our feasible region. So we now locate our four corners feasible region, where we are going to get, a minimum value. I will draw the graph on this. You can make a screenshot for this. So our next step is to plot the coordinate on the graph. So when our x1 is 0, our x2 is 40. When our x2 is 0, our x1 is 40. As I've done it before already. When our x1 is 0, our x2 is what? 30. When our x2 is 0, our x1 is 10. Then when our x1 is 0, our s2 is 20. So these are the coordinates of the points. So I have to apply this on graph. So I have to draw my graph. So my x1 and s2. Since there is no negative, that is the x1 is not negative, s2 is not negative, it means I can start my graph from here, because our constraint is what is greater than, it must be greater than or equal to 0. So from here I can use my scale that, because our highest number for here is x1 is this is x1, this is s2, this is x1, this is s2. My highest number is is x1 is 0. So my highest number of x1 is here is 40. My highest number of s2 here is 30. So I can let my scale to be 2 centimeter should represent 5 units. So I can say 2 centimeter represent 5 units. So if I say 2 centimeter represent 5 units, it means from here to here is 2 centimeter. How many units? 5 units, making 5, 10, 15, 20, 25. So from here, I can start if I start from here, if I say this is my x2, this is my x1. So my highest of s2 is what? 30. This one is 5, 10, 15, 20, 25, 30, 35. So I can begin it from here. I can begin my drawing my line, my horizontal line. This is my horizontal line here. Because our x is our horizontal, our y is our vertical. So our x is x1, our y is s2. And you can write your s2 here and your x1 here. You can write your s1 here, you can write your s2 here. It depends on how you want your variable to represent. So my vertical, this is my vertical line, this is my horizontal line. I want to make it to be. So this one is what? I represent this one as s2. I represent this line as x1. So it means from here to here is what? My scale that I use, that is 2 centimeter represents 5 units. 5 units on x1. Also 2 centimeter represents 5 units on s2, because we are drawing it on a graph. So in other way, I can say 2 centimeter represents both units, since it is the same unit I'm using for the same scale I'm using for x1 and also s2. So if you look at this, it means from here to here is what? 2 centimeter, which is 5 units. This is 10, this is 15, this is 20, this is 25, this is 30, this is 35, then this is 40. And from here is my origin, which is my origin 0, which is 5, 10, 15, 20, 25, 30, 35. So I can stop it here. So it means when our x1 is 0, my s2 is what? 20. So I can mark it. So it means when my x1 is 40, my what? s2 is 0. So it's on a line. So I have to join my 20 and 40 together. So I have to draw the line for it. So this is the line. So in this case, I can say, since it's the same, I can say 40, 20, then 10, 30, then 15, 20. So when my x1 is 0, my what? s2 is 30. I will mark the point here. Remember, it's an inequality. So this line, what this line gives us? This line is our x1. I can write it x1 plus 2s2 is greater than 40. So this is my first line, first constraint. My second constraint is 3x1 plus s2, which is what? When my x1 is what? x1 is 0. That's my x1 is 0. Here is my 0. My what? s2 is 30. I will locate the point. I will mark the point. When my x1 is 10, this is my x1, which is 10. My s2 is what? 0. This is 0. So it means I have to join the length together. That is 10 and 30. That is my x1 is 10. My s2 is what? 30. So I will now write the 3x1 plus s2 is greater than 30. So for my last constraint, when my 4x1 plus 3x2, that is my x1 is 15, my x2 is 20. My x1 is 15, my x2 is also 20 here. This means I will mark the point. I'm going to mark the point by drawing the line of it. So since I've drawn the line, so I have to indicate that my line is what? Last constraint, which is what? 4x1 plus 3x squared x2, so greater than 60. This is my line here, so I can write it here. That is when my x is 15, my y is what? 20. So this line is for this. I can write it here. 4x1 plus 3x2, indicate this one greater than or equal to 60. So I have drawn my graph. So my next step is to identify the feasible region. How can I identify the feasible region? For me to identify the feasible region of this graph, it means that what? I have to consider the corners of what? The corners of the feasible region by the shaded. That I have to shade the feasible region. So for me to consider the feasible region, you know that our objective function is minimize our objective function. It means our feasible region will be far away from the origin to the bounding point here. If it's our objective function is maximization, my feasible region will be from origin to this side here. From here to here is my feasible region, but it's minimized. It means it will be outside of the origin point to the boundary. So this will be my feasible region. So I will have to shade my feasible region. I will shade it. I will shade here, shade this as my feasible region. I'm going to shade this feasible region. So this is my feasible region. So this is my feasible region. Since I've shaded the feasible region, so I have to locate the corners of the feasible region. If you look from here, so from here I can indicate that this one should be A. That is from here it's 4. The feasible region, the feasible region 4. That I can indicate from here to here. It matches for here. It goes like this, then come back like this. So from here, this is our B. I can indicate this one as B. So this is our intercept, where the line meet together. And also, this is another intercept, which is D, where the line meet together. So these are our 4 corners of the feasible region. So we now have the feasible region. The feasible region is A, B, C, D. C and D are the intercept, that is our C and D is what? Our C and D is what? C and D is our intercept, that is C, D is the intercept of the feasible region. Since I've got my feasible region, so my next is what? To find the value of A, to find the value of B, to find the value of C, and to find the value of D, so that I can get my minimum value of the minimization, that is the objective function. So our A, this is our A. This is my A. So my A is 4 and 15. So on my x1, I have what? My A is what? 15. So I can write A is what? 15. On my s2, this is on y, which is what? Origin. That is 0. My A is equal to 0. I'm going to put 0. So whenever I see, I will put 15, 0. So it's indicating that my x1 is 15, my x2 is 0. So I'm going to find my B also. So my B is 15. That is, my B is what? On x1 is 40. My B on y is what? 0. That is, my B is 40, my L1 is 0. So I have to indicate it 40, 0. So I will go to my C. So I'm going to indicate this line. So I'm doing this so that I can able to count it. So if you look at this, this is what? 0. It means one also of this is 0 0.5, 0 0.5, 1.0, 1.1. Then another one is 2, another one is 3, another one is 4. It means here is what? Here is 4. That is my x1 is 4. My C is what? My x1 is, that is, my C is 4. Then on S2, I'm going to indicate it here. This is my S2. So this is 15. If you take 2, it will be 16, 17. Then another one is what? 18. So my S2 is what? On C is 18. So I will indicate that it's 4, 18. Then my D. So this is my D. So I have to, this is my D. So my D is here. So my d, if I count this line, my d will be 6, 5. Then another one is what? This is 5 already. Then 0 0.5, 5.05, then 6.0. My d is what? On x1 is what? 6. My d on s1 is 6. So I have to find my d on s2. So my d on s2, this is my d. So on s2, so this is 10. If you take 2 O's is what? 11. That is 1 O is 0 0.5. 10.0.5, that's 11. This is 12, and this is what? This is 10. Then I will take 2 O's, 11. Then this one is 12. So on my s2, my d is what? My d is 12. So these are the values of the corners of the 4 corners of the feasible region. So I will now put it in my minimize of my objective function so that I can get my minimum value for the objective function. So our z is 20x1 plus 10x2. So our a is called what? 15, 0. It means whenever I see x1, I'll put 15. Whenever I see x2, I'll put 0. I have 20 is equal to 15 plus 10 is equal to 0. So 20 times 15, you multiply 20 by 15, you are going to get 20 times 15, you are going to get 300. 10 times 0, there is 0. So my value for a is what? 300. So I will test for b. B is what? 40, 0. That is 20 is equal to what? 40 plus what? 0, 10, 0. If I multiply this by this one will be 0. If I multiply 20 by 80, I'm going to get 800. So I'm going to get 800. So 800 plus this is 800. So I will take the point for C, 4, 18. I'll put it in my objective function, which is this 20. Our x1 is what? 4. Our s2 is what? 18. If I multiply 20 times 4, I will get 80. Plus 10 times 18, I will get 180. So if I add it together, I'm going to get 260. So I will test for D. Our D is what? 6, 12. Means 26, then 10, 12. 20 times 6, 120. 10 times 12. 10 times 12 is also 120. 10 times 12 is also 120. So I'm going to get 240. So 240. So the minimum value of this, so our A is what? A is what? 300. This is what? B is what? 800. The value of C 260, and the value of this is what? 240. So the minimum value of this, is what? 240. So therefore the minimum is what? 240 value occur at what? At 6, 12. That is, our x1 is 6, our s1 is 12. So this is our answer. That is, the minimum value is 240 occur when occur at 6, 12. At x1 is equal to 6, at s2 is equal to 12. So this is how to draw a graph, how to represent linear programming problem, that is drawing it as a graphical method on a graph. So you can write your title of the graph here. Your title of the graph will be you are plotting s2 against x1. Then you now indicate the scale you are going to use. Then this is how to draw the graph. So we have gotten our minimum value. That is, our minimum value is what? It falls on 6, 12, which is 240. At x1 is 6, and our s2 is equal to 12. So this is the solution for the problem of linear programming problem. Thanks.